And thank you for coming to the call. Today, I think, is our 124th meeting of the Dash community. So tons of meetings. What I'm showing on the screen are the notes from the last time we met, and with Jimmy or Junhua presenting and showing us the BMV2 data plane app. So these were the notes from last time. And we were maybe going to pick up on some other PRs and issues today. The summary last week was we had 5 in our completed queue, and we actually jumped up a lot in progress because we actually have a lot going on. I think Junhua and Riff have been submitting a lot of PRs. So then, of course, the longer meeting notes are down here, and the items we have in play. And I actually had to ask Jimmy and Riff today about, is the data plane app different from the other data plane app that we had? And they were helpful in telling me that one is customer based and one is based on our implementation. So anyway, did you guys have any questions or anything about the notes from last time? Oh, hi, Andy. So I'll go ahead and show you. Can you see the project screen here?
Yep.
Okay, great. I was wondering if anyone wanted to go first, if you had a PR or one that you wanted to cover before we looked at these different ones. In the pull request queue, I can see attributes on ENI for reverse tunnel, and I can see the MSEE failover, a couple other things. Did anyone want to go first?
Yeah, if we have some time, we can probably go through the MSEE failover handling in the ER gateway bypass design. Yeah.
That sounds good. That sounds good.
Yeah, we can
So it looks like the design is reverse route table based, which is flexible, powerful, and complicated. And with this change, we're going to simplify it. Yeah, go ahead, Riff. Did you want to present, or would you prefer I do it?
Yeah, I can present.
Okay.
The change is actually really simple.
Mm-hmm.
Just change the reverse routing part.
Mm-hmm.
Okay. Can you all see my screen?
Mm-hmm. I can see.
Okay, great. Yeah.
Riff, hey, I also pinged Mukesh. I don't see Marian also here because this is an important topic. I thought can have them as well.
Yeah.
So
I'll ping Marian. I'll ping Marian.
Yeah, please. Yeah, I think they both are reviewing, right? So it's better that we have them.
That is actually true. How about this? We can still do the topic, then we can send the recording. I think we probably will need to close with an offline anyway.
Okay. Yeah, I think I pinged. So if
yeah, I just pinged Marian on Teams, and then who else did you say? Mukesh.
Yeah, Mukesh also Mukesh. I pinged on Teams.
Yeah.
So.
You're teaming him too? Okay.
Yeah.
Okay.
Yeah, Mukesh said he's joining.
Awesome.
That's even better.
And Marian said he's on a previous call. Well, he just said give him 5 minutes. So.
Okay. Yeah, I think I see Mukesh joined, so we can get started. But
okay. Yeah. Thank you.
Okay, great. All right. So basically, this goes to the design. As we can see, majority of the things is actually happens in section 5, which is doing starting from here, MSE selection and failover handling. So basically, what happens in here is that originally we are what we were doing is that we were using the reverse set of a reverse. We are adding a reverse table then to do a lookup on the forwarding path, and so then we'll determine how the reverse tunnel gets selected. So the reason of that is because we have certain cases and maybe coming from like the customer will have the per VNet routes, which determines the tunnel. However, in the first phase, this seems to be like more complicated than what we need, because essentially the first one is that we just need to make the packet or the return packet coming back to the MSE where the packet actually sent from. So so that's why we update the background here to say the return traffic basically is routing back to the MSE where traffic is originated. So that means that when MSE failover happens, we need to update the reverse side of the tunnel on all the existing flow to point to a new MSE. So if let's say if we have two MSEs, and then MSE1 fails over to MSE2, so that means all the traffic that originally coming from the MSE1 now needs to be or returned to MSE1. Now it needs to be returned to the MSE2 because the new traffic will come from the MSE2. If we have a multiple, it's the same thing. So whichever it comes from, it will forward back to whichever the MSE then then traffic is coming from. So then simplifies the whole pipeline, because as you can see, it's basically traffic is determined by the traffic, not determined by the flow lookup or the table lookup anymore. That means the device selection is actually really simple. So basically in here, the device selection is just like when the flow gets created, we pick up the tunnel from the flow itself. There is no lookup anymore. We just reverse the tunnel. However, we still needs to change the source IP in the reverse tunnel, and that is based on like it's pretty much on the ENI. So every single ENI will have just one single IP. So we add the ENI level source IP in here. So that's the only attribute we add in this case. And then when MSE failover happens, we need to update the flow. So we still use the same like flow resimulation. However, when flow resimulation happens, we're not doing a reverse side of the table lookup. We just pick up the reverse side of the tunnel from the packet. Let's say there is a connection. The MSE forwards the traffic to the smart switch or to the dash pipeline, and then at that time, like let's say flow resimulation happened, okay, and the next packet then coming from the MSE side will actually triggers the tunnel triggers the tunnel updates, because only the MSE side will contain the reverse tunnel information. That's the only place that contains the reverse tunnel information. So basically the flow resimulation just follows the the standard or the regular case of the flow resimulation. It's a forwarding side of the flow, a forwarding side of the traffic that updates the flow. So this is basically the failover handling, and this updates the reverse side of the tunnel. And because when doing the flow resimulation, I think the maintaining the per connection consistency, like these things are not changed, we still need it. Flow resimulation on the return path. So when usually when flow resimulation happens or flow gets updated when there is a packet coming from the forwarding path, which in this case is MSE to the private link or to the the VNet. So in this case, the flow resimulation on the return path means that there is a packet coming from the private link coming back to the MSE, and in that case, what should we do? So as we can see, the reverse side of the tunnel, the tunnel information is not contained in the packet. So that means that if there is any return packet that comes back while the flow resimulation started, there is no way we can actually update the flow. So we just forward the flow as it is until there is a packet coming from the forwarding path. So without a lookup table, yes, this will introduce a slightly longer like downtime because we're waiting for the next packet coming from the MSE side to actually update the flow. However, this behavior is expected, it will be acceptable at this time, and will improve like this behavior with a better model in the future. So right now, this one, like the downtime is expected. Okay, and then the last one is still like the fast path packets or fast path flow. So for the fast path flow, everything is still the same. There's no change in this in here. We still need like keep the forwarding side of the tunnel, and the reverse side of the tunnel is not really like changed by or managed by the fast path packets. So we don't really need to worry about that. So this behavior is the same. All right. So that's pretty much all the changes. As we can see, instead of introducing the reverse side of the tunnel, tunnel table, tunnel member, like all these like objects, we simply just add a reverse tunnel source IP on the ENI, and that's pretty much it. So that simplifies the whole design, and that's it. Yeah, that's all the changes. Okay, any questions?
So
Riff,
for
go ahead, Vince.
yeah, so yeah, quick question. So Riff, in this new attribute, right, the reverse SIP, the expectation is every return packet will take that as the source IP, right? There is no override or no exceptional cases, right? So yeah, I mean, the proposal here is to always use this IP, right? Is that correct?
Yes. It's always use this IP.
Okay. Yeah, Marin,
Yeah.
go ahead. Mukesh. Yeah.
Yeah, I want to go to the section with the resimulation. You said that the reverse path, resimulation, and the return path. There is a statement saying that packet should be sent to the old destination. I don't think that's even possible logically, because as you said yourself, there is no tunnel destination IP encoded in the packet, and there is no forwarding table that has this information.
This is actually not true, because when let's say when the first packet, the SYN packet comes in, right? So the SYN packet lands on the pipeline. At that time, yeah, let's go to the here. When the SYN packet comes in, comes into the smart switch, the packet goes through the pipeline. In this case, we'll create a pair of flow, one forwarding flow, which contains the forwarding side of the tunnel. The reverse flow will contain the reverse side of the tunnel. So the flow is always there. We don't have to do a lookup for every single packet, because then we'll just hit the flow and forward it. Return packet is the same. Comes back, hits the reverse side of the flow, which already contains the reverse side of the tunnel. So there is nothing that we actually need to do a lookup. Even with the reverse table, that approach is still the same. It's only just one single lookup when forwarding path, like the packet lands on it. There is no like continuous lookup to the table. Just like when the packet lands on the pipeline do one single lookup, or then creates a flow, and then we just stick on the flow. So,
but you said that the packet is supposed to be resimulated.
Yeah, packet is being resimulated, but the flow is not deleted, right? The flow is still there.
But now you're putting kind of additional assumption on the resimulation. When the resimulation happens, I don't carry any of the previous previous flow lookup information together with me. I'm doing everything from scratch.
No. That's not actually true, right? So flow resimulation
I
always
treat it as a new flow. Why
always
would I?
Yeah. So flow resimulation always cares about some of the original like flow information. For example, like a private link. Private link is that okay? We will not update the the 46 and all these things. We will have the flow resimulation scope, then remove some of the things from the resimulation. So you always care about the flow information. You cannot just like remove the flow for good.
Can
Flow
you
resimulation is not flow
explain
delete.
the private link example?
Yeah. So for example, like a private link, and or any cases that we need to do ECMP-ish behavior, right? So in that case, we need to save the destination inside of the pipeline, and that information is saved in the flow. So let's say if the ECMP group like changed or whatever, right, we forward to the. So what happens is that instead of forwarding to one destination, we will need to forward to the next destination. Well, yeah, we will be forwarded to the next destination if we don't save the flow, because the ECMP group changed, right? So based on the same hash, ECM group like member is changed, then it will send to the other side. However, like things like private link, we cannot do it. If you send to a different destination, what happens is that you break the
You're
connection.
talking about the mapping entries attribute, either resimulate or not.
It's the same, right? So basically, it's
Is that
basic
the attribute you're talking about?
which attribute? Sorry.
The resimulation enabled or resimulation disabled attribute of the mapping entry?
There is a resimulation disabled flag. Yeah.
So you're talking about that. Yeah, but that one is embedded together with an entry, and I know to either embed this information with the flow or keep it separate from the flow and have a pointer to that part of the forwarding information. Here, I have no indication. It's just there is an assumption that this part will be kind of outside of the flow data. Like there is nothing that indicates to me that it has to be resimulated or not resimulated. This specific field in the packet.
No, this is not actually true, right? So this is the full flow resimulation. You know, like this flow gets resimulated because on the ENI, like everything is resimulated.
So I think here, Marian, the resimulation indication is coming from the ENI, and the source IP of the packet has changed. So it's a indication for resimulation, right?
But I don't know that the source IP has changed because we are getting the return packet. We're getting SONiC. How do I know that?
We're getting SONiC. We don't need to know the return IP is changed, right? We just forward to like as it is. We're not changing the.
But so there is no. There is no. You want two conditions to happen. You want the packet to be resimulated, or you don't want this packet to be resimulated.
So there's resimulation.
Do you want the SONiC to be resimulated?
Receive the traffic.
I'm sorry?
Yeah, sorry, my machine is having some trouble.
Oh, actually, your audio is better now.
Oh, okay. Yeah, so let's.
I think if we can get with an example, then that might clarify.
Did we lose Riff?
Yes.
Uh-oh, he may rejoin. There he is. Okay.
Okay, so I joined slightly later. So the question is basically when we resimulate the packet, like what will be the indication of this one?
Yeah, Michael, I think this is about that MSE failover scenario, right? Where the source IP in the packet is changed. And that's where we were discussing about the resimulation scenario. Like during MSEE failover.
Mm-hmm.
Yeah, basically, I'm not
Yeah,
sure if.
whoops. I'm muted. I'm talking. Oh, yeah, my machine completely crashed. So it just went like, yeah, it just
Boom.
like shut itself. Yeah, something goes wrong with my laptop. But anyway, and this is why I lost the screen share. So basically, what happens is that let's start from the beginning, right? So when the first packet comes in, we create. So the requirement is that we create a pair flow. We create a reverse set, like forwarding flow, and we create a corresponding like reverse flow. So reverse flow does a reverse setup transformation. It has all these actions, which includes adding a tunnel, right? The forwarding set adds a forwarding set of tunnel, does forwarding set of transformations. Okay. When the flow simulation request comes in, so we actually have a HLD talking about a flow simulation. So
and the resimulation request is per ENI, just to make it clear.
Yes, it's a full flow simulation. It's per ENI, and when the flow simulation request comes in, we cannot remove all the flows, right? So we need to keep all the flows running, and update the flow when the next packet comes, then going through the pipeline and do the same, right? But we cannot just remove the flow. So
yeah, that's fine.
Yeah, and in this case, let's say the flow resimulation happened, right? So the forwarding side of flow and the reverse side of flow, they all exist. So when the forwarding side of the packet comes, it will resimulate like the the policies, because like the policies the policy in the cloud is usually like asymmetric, right? So you need the right side of the packet that creates a flow to actually update the flow. So you cannot use the other side of the packet, because outcome could be different. They could just cause the packet to be dropped or flow to be like deleted. So we cannot really do that. So only the forwarding side of flow can actually cause the flow to be updated. So that's the thing. Here we are doing the same. So forwarding side of the packet will update the flow. However, for the return packet, the return packet lands on the the dash pipeline, because the reverse side of flow is already there. So we just stick on the flow for the packet.
So you expect the reverse packet to never actually trigger resimulation and just be forwarded?
Right. Just forward it, yes. Reverse side of a packet should not trigger the or update the flow, triggers a flow resimulation. The reason is that the echo on the both end can be different. So if we actually use the reverse side of the packet, triggers the flow resimulation, then what happens is that you may hit a different echo, then cause the packet to drop, and then it will just cause the flow to be deleted. And then it's actually unexpected behavior. So flow
isn't it possible? Okay, so but that's related to ACLs. But isn't it possible that it's actually in reverse, that incoming flows are allowed due to, according to ACL configuration, but outbound are not allowed, and then outbound will never be able to resimulate?
Yeah, outbound is not like resimulates a packet, and that's actually the thing is that to support what you are referring to, like the return path will actually resimulate the flow. That's where the improvement is coming from. So we'll publish a new thing that covers that. But right now is that we expect all the packet only from the forwarding path updates the flow, but not the reverse side of the path.
But you didn't. I don't think you answered my question about the ACLs.
Okay.
Isn't it possible that there is an ACL configuration that only allows inbound and blocks the outbound, and the connection can only be opened in the inbound, not for private link, but for other types of services?
Yeah, let's say you have
Just VNet to VNet.
VNet to VNet. Okay, and in VNet, like at least in Azure, or I think AWS is the same. So basically, when you create a VM, what happens is that you have a default echo, right? So the default echo will usually will do something like this. Okay, from the VM going to the internet outbound side, 100% everything is allowed. So you can just access internet as long as you have an outbound gateway or whatever, right? Inbound side, everything is denied because you cannot just like allow any internet to access your VM as long as you have a port. So inbound side is everything is denied. Outbound side is everything is allowed. You can pretty much simplify it like this, right? There could be like 1-2 ports like get opened because you need to SSH into it, but whatever. In that case, if you let's say you want to create a connection right from the VM to the internet. Let's say you want to go to the google.com, and you create a connection from the from the VM to the internet, and then passes echo on the outbound side because it allows it. So the connection gets correctly created. All right. Let's say there's something happens, you add a new echo group, and new echo group, no matter which cloud provider, it will actually do a full flow resimulation because it doesn't know like which flow needs to be deleted. So you just say, okay, let's just resimulate all the flows. Let's wait for the next packet comes to actually go through the pipeline. Now, if the outbound side, if the packet coming from VM to the internet going through the pipeline, it's all good because outbound is always allowed. The connection will still persist. If the inbound side, which is the return packet coming from internet to the VM, resimulates the flow, what happens is you hit deny all rule inside of the inbound side of the echo, and then cause a packet to be dropped and flow to be deleted because this flow is not.
No, I get the example that you are giving, but again, you're starting with the configuration where only VM can talk to someone and no one can talk to VM. I'm talking about the opposite. That I as a customer am not allowed to create ACLs where I will allow access to my VM from specific IPs, but I won't allow the VM to talk to anyone.
I think the example is actually the same. It's just like which direction you want, right? So
no, but your requirement is to resimulate on the outbound, and I configured the opposite ACL.
The requirement is simulate on the whichever the direction that flow is created. There is a inbound.
But there is no indication in the flow table in which direction the flow was created.
We can always add it, right? So it's about implementation. If you're talking about a flow API doesn't have it, we can add it over there.
No,
but
I'm also confused, Marian. Like we always create, like in this example that Riff mentioned, the flow is created based on the outbound flow. So the whole point
because
here
it's
is,
private link.
But
because
the resimulation request is for the path that created the flow, which is in private link. It is outbound.
No,
but if it is some,
hold on. If I'm looking at the APIs, the resimulation is for the ENI. It's not for the path. It's not for the direction. It's just for ENI. There's nothing telling me to resimulate out.
The ENI, but the flow update is per flow.
correct.
So full flow resimulation. The expectation is that the flow resimulation request completes like really quick. It's just like, okay, there we go. All flow needs to be updated, and then
quick question. On the VFP side, right, the existing implementation that we have, do we also keep on the flow information in which direction it was created or not? So basically, I'm just curious if we have something similar in VFP.
Yeah, we're doing pretty much the same thing as the VFP because when the flow resimulation happens, I actually involved when designing that flag. So when flow resimulation happens, what we are doing is pretty much the same. It's like we have a pair of flows, and those pair of flows sticks. When the next pack comes, it will go through the layer by layer, and depends on which layer gets resimulated. We update the layer flow, then goes to the reunified flow.
Yeah, that's the updating layer. But I'm curious, basically, from the flow representation perspective in VFP, do we actually store in which direction the flow got created, or not? Like from the data perspective in VFP.
That's actually
because I don't believe we store the direction, right?
Yeah, what I remember is that they actually do because they in output of the flow information, we can very explicitly say okay, this is actually reverse flow. So the flow you listed over there, you will list all the flows. And if you want to list the reverse side of flow, you can actually see like this is actually the reverse side of a flow for the flow. So it's
Well,
more
it's
like
not in Dash.
Yep. But we can so if you are talking about like flow APIs, like we can add it. Right. And in the flow API, we actually have a reverse flow key that determines like which side of can use to determine like the reverse side of the flow. So it's kind of already in there.
Because Riv, I think my question is like this, right? Because one thing is the requirements from the point of view of resimulate the flow if, right? That's the one discussion that we have right now, right? But the second discussion is, do we want to amend the flow table definition to have some additional flag? Because like that in my opinion, this should be kind of like separate discussion, because like flow table usually takes the most memory on DPUs, because there's basically lots of flows, and every time when we are adding even a single flag for every single flow, this can potentially have impact on the memory requirements per flow, in this case the entire flow table, and how many flows we can keep and how much memory we have, right? So the discussion, because like you mentioned at some point basically that like we can potentially store it as a flag, which is kind of like just implementation, right? But for me the actual data structure of what exactly is being kept per flow, it's actually very crucial, because basically this is where lots of memory is being used. So that's why I understand the requirement from the point of resimulation, right? But at the same point, I'm curious from the point of view, do we actually need to create additional flag on the flow?
I think this
or is some different option? Yeah.
I kind of understand what you're saying, but no matter which option you would like to go, right? So essentially, it's like we need something to specify. Like, like concept-wise is pretty much just a flag, like just one bit flag, whatever. But implementation-wise, it could be like different. Like as long as we have a way to say, okay, this is actually the creator side of the flow, that should be good. Because this is more like a very generic way, or generic requirement when we actually talking about flow resimulation. We need to know like which side of a flow actually does the creation. Otherwise, it's just like yeah.
So I think the flow simulation HLD, we need to clarify this, Riff, like what can trigger or which flow must be resimulated, right? So
yeah, I think we actually did, but yeah,
is it reflected in any way in the behavioral model and in the APIs that we have this notion, and this is going to be required? Because I think that's why it's not well understood, because we never talked about it like that. We always talked about there is a notion of direction in the pipeline, but not in the flow.
So in this same scenario, Marian, that what you are saying is in the current behavior, it will create a new flow instead of resimulating the existing flow if the packet comes from a different source IP.
Well,
right?
I'm saying that it's completely not going to work if we don't have a notion of direction in which the flow was opened, because you rely on resimulating a thing that does not exist in the forwarding database. It was learned. So the end result would be, without this information, like that we need to simply forward the reverse packets. It would be tried to be resimulated, and then there will be a missing information, and it will be dropped, because we cannot get this information from anywhere. So there is nothing right now telling us that, okay, this packet is a reverse packet. So
no, but this problem can happen even today if the first packet, or if some packet is coming from the.
Oh yeah, definitely. Same thing with the ACLs, just a different syndrome. It will be dropped due to ACLs.
Yeah, I think so. I think that needs to be like aligned, right? So basically, then we need the notion of the flow directions.
Right. So you need to define that. There is only a pipeline direction right now.
Okay. So,
Oh,
I mean,
sorry.
if we take the resimulation part aside, is the rest of the things like in the proposal, right? Like the reverse SIP um, and the flow creation for the reverse MSE gateway IP, those kinds of things. Are we good with that, or is there any?
Oh, there is like one more thing that I left comment on that. This is a learning or an implicit behavior, so we need to also have just I don't know, a basic ENI level flag or something that would tell us learn reverse path, because alternative could be the previous proposal, the ECMP. So we need to not make these assumptions that it will be learned. We need to have some sort of API that will tell the data plane to learn this IP address. Because it's just written in text. It's not really propagated in the software.
Yeah, I had a similar question as well. So how do we determine which case the packet should be forwarded to the PA in the ENI versus which case it should be learned?
Sorry. Which?
So this is so basically this model is completely different from the existing VNet to VNet model, right? Where everything is statically configured, the tunnels are statically configured, the underlay dip is statically configured on the ENI, and we just forward to a specific underlay dip that is statically configured, right? Either it's in the outbound direction, it's in the underlay dip of the mapping entry, or in the reverse direction, it's in the underlay dip of the ENI. So that's the existing model. So now what we are saying is in the reverse direction, we should not take the static config. Instead, we should dynamically learn from the packet.
My
So
understanding is even for VNet, we send it to
Yeah.
the same reverse path, right? I'm not.
Yeah. It's basically like VM to VM case, or where you just learn the reverse side of the thing from the tunnel itself. There is no policy to indicate like reverse side of the tunnel,
Yeah.
like in the pipeline. Yeah.
so there is an underlay dip, underlay IP in the ENI, right?
That's yeah, but
Static
that's for
config.
the forwarding pass.
Sorry.
But that's for the forwarding pass.
Yeah, for the reverse packet, right? When a packet comes inbound, we send it to the underlay IP of the ENI.
No, Mukesh, because when the packet comes in the reverse direction, it is expected to hit the flow.
Yeah, and the flow is created from the underlay IP of the ENI, is my understanding, from the static config.
That should be on the forwarding pass, right? Not a reverse pass. At least in the dash pipeline, that's for the everything we have over there is for the forwarding pass. We actually never modeled anything in reverse pass of the tunnel. In the policy side.
So there is in the SI attribute, there is a VM underlay dip. Or if you can go to the dash itself, there is.
I think Mukesh, that is for the packet originating in the inbound direction. Like if the first packet is on the inbound direction, then we go through this.
Okay.
Yeah, that's when the TNI underlay dip is IP is taken. That's what I remember, but because when the flow is created, it is depending on the PA of the source IP. The PA is the source IP of the packet, and that's how it is created back. But
Okay. So the understanding is that we are always learning from the packet.
Right.
We
Right.
never use the static config.
Yeah, even in the VNet. So basically here we just like use the exact same behavior as VNet to VNet. Yeah, because then pretty much just satisfy the requirement. When the MSE failover, we relearn it. That's it. The behavior is basically the same.
Correct. And I think Mukesh, Marian, that's how the test is also being implemented. Or like we expect the packet to be sent from one direction and flow is created and coming back in the same transformation. So there is something different than we need to discuss. Yeah.
Okay, I
Okay.
need to go back and check this.
Yeah. Let's
implementation.
check and
Yeah.
clarify. Yeah.
Yeah, let's check and clarify.
So it sounds like this one needs more work then.
No, I think what we discussed is slightly different. That's not fully related to RISPR, but
Oh, okay.
I think
Yeah.
RISPR is like the action is how to determine the direction for the flow, right? So that's something we have open.
Okay, and I think I captured that. Okay, so any more on this one today, Riff?
No.
Also, one more
Oh,
question.
sorry.
So
Yeah, sure.
Yep.
the ENI MAC is in the, so when the first packet comes, the ENI MAC would be in the destination.
The ENI, sorry, which MAC? The ENI MAC.
Yeah, would the first packet would have the DMAC as the ENI MAC, is it?
So is that for determining the direction, Mukesh? Because there is another attribute that sets what MAC should be used to determine the direction.
Right.
Yeah.
Yeah. So I think I got my machine back. So if you look at the PR, and yeah, let me actually really quickly pull the thing. Yeah. Hopefully my current headset is not causing any echoes, because yeah, it's essentially a speaker now. Yeah. Okay. So and yeah, here the ENI MAC handling cache in here. So yeah, so basically on the ENI we have an override attribute determining if it is using a destination MAC and a source MAC. Yeah, so if it says like destination MAC, then we'll use the destination MAC to do the lookup. And in this case, in the gateway bypass case, it's always the destination MAC is ENI MAC.
So this is not an ENI level attribute, right? So what you're saying is based on the incoming VNI of the packet, it needs to determine whether to use the source MAC as the ENI MAC or the destination MAC as the ENI MAC.
Source MAC has ENI MAC and our destination MAC has ENI MAC.
That decision is based on the VNI. So the direction lookup is based on the VNI, right?
Yeah, it's based on the VNI, yes.
So we are saying that all packets coming from the MSE gateway will have a specific VNI, some fixed VNI.
Yeah, at least a fixed ENI, yes. And then the ENI will have the will have this attribute.
No, I mean the VNI.
VNI, yes.
So,
VNI, yes. Not the ENI.
It's the trusted VNI, right? So
yeah, it's this thing. It's basically this thing, right?
So all packets coming from that MSE gateway will belong to the same VNet. How do we know which VNet?
So this is not the VNet, right? So this is basically you have a list of VNI. All these VNIs will have that attribute to say which MAC you're going to use, and that maps into like here. You have the VNI or the VNI, the same thing. And this VNI will be like the ones we use in the MSE. So if you found the VNI, then says it's a destination MAC lookup, then look up the destination, find the ENI.
Okay. So yeah, I'm just trying to understand how traffic from the MSE, from a single MSE gateway can, if they can belong to multiple VNets, is that possible?
Yeah, it is possible.
Because each ENI is mapped to a single VNet, right?
No. So I think you are mixing like two things. So MSE is a shared resource. You can serve like multiple VNets. There's no problem with it. VNet is just like something like we created is like virtual network, right? So it's another concept. So they're completely different. A single MSE can serve a lot of VNet, and there is no problem on that.
Yeah. So my question is, if from the same MSE, if there are two packets, one packet is to VNet 1 and another packet is going to VNet 2, would it use two different ENIs in that case?
Yes, because the VNI goes with the VNet. So yes, they will use different VNIs.
Different VNIs or ENIs?
VNI.
The key.
So, okay, so the trusted VNI would be different for each VNet. Is that what we're saying?
No, I think
I think that's
question what Mukesh is asking is when the packet comes from the MSE, will it comes with the VNI of the VNet, or will be a list of trusted VNIs, let's say like 1 to 256 for
no,
the
I
sake of
think
argument?
the trusted VNI is a different thing.
Okay, so that means it.
Yeah, the trust VNI is for other scenarios. It's not for MSE scenarios. Yeah.
Okay, so that means we are saying like it comes with the VNet VNI.
Yeah.
Right.
So if
VNet
it comes
VNI?
with the VNet VNI, how do we know the direction lookup? Right, because here we are saying direction lookup is based on a fixed VNI. We determine whether it's DMAC or SMAC. But if it's a VNet VNI, then we cannot determine that, right?
No, sorry, Mukesh, it's coming from the VNet. Doesn't mean it's a VNet VNI.
Okay.
Yeah, it's a list of VNI. It's not a trusted VNI. I think we never actually talk about trusted VNI in public space, but anyway, the trusted VNI is for different scenario. Okay, it's not for this scenario because we only have a few trusted VNIs, and the MSE will have a list of VNIs that you can think like every VNet will have its own VNI, and the packet coming from the MSE will have that in VNI being used or that key being used. Then if we found those keys over there, that means that we will need to do the destination MAC lookup. And the direction lookup is basically a VNI table, right? So it is pretty much like the key table. And then from there, we look up the key, we look up the VNI, and using that VNI, find which MAC to use, then use that MAC to look up the ENI. Does that make sense?
Yeah, so I'm not clear why. So we already have a set of VNIs for the VNet. And then now we are coming up with another complete new set of VNIs for the same set of VNet. And then making it, using that just to make sure that the ENI is in the ENI MAC is used in the DMAC of the packet. Why not just put it in the SMAC, right?
Sorry, I probably didn't fully understand the question. We're using that.
So all of this. So we are inventing a new set of VNIs for all the VNets, right? So the VNets already have a set of VNI, right? Each VNet has its own VNI, right? And then we are saying now that for the MSE, we don't use that VNI, but we use a completely different set of VNIs. So each VNet has a duplicate VNI for the MSE case, right?
Yeah, the MSE.
Then that will be populated in the direction lookup, and all this is to just make sure that the MAC address is in the DMAC. If the ENI MAC was in the source MAC, then none of this would have to be done, right?
I think even right now, the MSE MSE is sending a different is sending the VNI, then it's not the trusted VNI.
No, but hold
That
on. The
will be
discussion about the source and destination MAC location, right? I think the idea is that MSE should not be treated as the VM behind the basically the card, right? We should be treating this from the point of view as external traffic that goes. It's kind of like if there is like a DPU, right? And this DPU may receive traffic from the internet and also send the traffic to the internet, right? Or may receive traffic from the VNet and send traffic to the VNet, right? And the idea MSE is not really something behind the DPU. So I think we should introduce the idea of harpooning, right? Because the idea is that in the current pipeline, we kind of like hack it in a way that we put the MSE to be as if it is VM, but it's not the VM. MSE basically is the traffic that goes from the outside, which is kind of like traffic from the other VNet, goes to the card, evaluates basically some stuff, and goes out. So basically, destination mark is the mark that defines ENI, not the source mark. So
Yeah,
sorry, I'm not quite sure if you
the,
already started discussing this, but basically the stuff that basically we hack the MSE kind of without introducing harpooning and make it as a VM, right? This was never the intention, right? I think in general, right? We wanted this to basically kind of bounce the packet out because we wanted this VNI to VNIC to behave as kind of VNIC without the attached VM. So basically, the VNIC that can basically just work as a switch that will forward the packets. So basically, receive packets only inbound from either one VNet, those kind of stuff, and send it to outbound.
Do you mean that those outbound and inbound definitions in the pipeline don't really make sense for the use case?
No, it makes sense. Just the idea is that this pipeline should be evaluated twice, like from the point of view of the harpooning, right? I understand that basically for the first scenario, which is that we are trying to do the MSE from the point of view of on the existing infrastructure, and we kind of try to hack around it, right? But the idea here is that MSE is not a VM behind the basically behind the DPU. Basically the
right,
DPU should be just working as a switch.
Doesn't really make sense then.
Yeah, so for all purposes here in the current dash pipeline, it's modeled as a VM.
Yeah, I think for the next phase, I think we should start a different conversation like offline first. Yeah, otherwise it will be too confusing at this moment.
Yeah,
but I think just coming back to the topic is that for the VNI, I think we just like is not a part of the the trusted VNI thing, right? And it is actually the different set of VNI in my understanding. It's not the VNet VNI because it's not really the VNet.
let's
because
call it
because
it's a reserved VNI, right?
Yeah.
For determining the MSE traffic, and then that VNI will be used for setting the direction based on the inner source or destination MAC. I don't think there is a big confusion here because we need to use that. It's not the VNet VNI. If that's clear,
yeah,
right?
But the source, I want to just make clear that basically the stuff we are using source and destination MAC, right? In my opinion, like always the destination MAC should be used. The stuff that here basically, for example, the source MAC is being used in this kind of stuff.
That depends on what MSE sets, right, in the packet. Like if MSE sets the ENI MAC in the destination, then that's the destination MAC. If it is in the source, then so that's why it is flexible here, right? So you can if you don't specify anything, it is the destination MAC.
Yeah, Michael, I actually understand what you're saying. Like in this use case, yes, always we will use the destination MAC as a year MAC, but conceptually wise, like we put in both as a override, so it's like flexible.
No,
yeah,
but I'm not quite
creating flexibility.
Yeah, but it's flexibility based on which condition? Based on the VNI ID?
So based on VNI. Yeah, any case VNI is what is used for direction, and then how to determine the ENI is where we have this flexibility.
Okay,
yeah, I think we can take it.
Let's take it offline because I'm curious. For example, if let's say two the same ENIs, because like MSE will be mostly behind kind of like multiple ENIs potentially, right? And the same as we have multiple gateway instances, right? What if the two gateway instances land on the same switch? Will this still work? I don't know. But potentially. I mean, let's take it offline. This source destination, right? Yeah.
Yeah. So that part should be fine. Right. If you multiple VNIs land on same same switch, well, the VNI is pretty much assigned, based on some rules.
Okay,
right?
so this work. Okay.
Yeah.
Okay,
we will mix use of the VNIs. Like every VNI has its own usage. But I think for the hairpinning, let's chat offline first. Because otherwise it could be like really confusing. Yeah.
Yeah, I think we should introduce hairpinning as soon as possible, right? Because this will basically make the entire stuff.
No, I think
clean.
Michael, that one we have to. We have to
Let's close that offline.
close
first.
that offline.
Yeah. Otherwise, you will be like too confusing in if we just like
Yeah.
talking about that concept. Because there's no background. There's it's much bigger.
Okay, sounds good. Yeah, that's okay.
Yeah. So let's chat offline first. Yeah.
So it sounds like
Okay, so what is the scale of this direction lookup table now? How many VNIs should we expect?
Oh, I see. So right now, I think in a it won't be larger than the number of ENIs on because it's like 1-to-1, right? So at maximum 1-to-1. So it won't be larger than the number of ENIs we're going to support in the scene. So it's like a few tens. I forgot the exact number. Is like 32 or 64.
So 32 ENIs is what we anticipate,
Yeah.
but I think
No,
for the sake of
it's dependent on the MSE, right? Like, why would it be based on the ENI? Or rather, based
Because
on your initial comment, Riff, I think, are we saying there will be one VNI for each VNet, or there will be just one VNI to represent all the MSE?
Because it's one ENI for each gateway, so it's 1-to-1. So at maximum you won't exist a number of ENIs.
No. So I'm confused now. So are you saying there's only one ENI per gateway device?
No, there is okay. So every single ENI is pretty much a gateway, right? So every single ENI will goes into like will use a key with basically VNI to talk with MSE. Right. So when the MSE sends a traffic, it will use that key to the smart switch or dash pipeline. And now you can see the number of the VNIs we will be adding will never actually exceeds the number of ENIs we will be adding, because it's every ENI has its key, right? So at the maximum is a 1-to-1. Well, if multiple ENIs well, we actually have multiple ENIs sharing the same VNI. Actually, it's basically at maximum like number of ENIs.
So what would be the number of ENIs? So that itself is a question.
32 or
because
64?
so if one MSE device wants to send to 10 VNets, right?
Yeah, they use different key. That's it.
Different ENIs or different VNIs?
It will be
same ENI but different VNIs.
It will be different VNI as well as the ENI, because if you send to different VNet, that's different gateway. So it will be different ENI, and it is also using different VNI as well.
So when we say 64 ENI, so then that 64, there will be only 64 VNets?
Like in a single.
I think VNets is multiple. If we look at the
so I'm
requirement,
trying to get the
relationship.
so I'm trying to get the relationship between the ENIs, VNets, and the VNI. I mean, if maybe I don't know.
Should we draw this
take it to
out?
next call or something?
Yeah.
Yeah, I think the in the but not the gateway bypass. I think in the private link. Is that in gateway bypass or private link? Yeah. So if that one is not clear, I can definitely like put a table on there. I somehow remember we have a resource modeling table somewhere. Yeah, this is the private link, and And yeah, in here, I can put the require like the VNI, the scale of the VNI in here, but basically it is a number for ENIs.
Okay. Yeah, I just want to understand the relationship between the VNet and the ENI, right? So if we say that from a given MSE device, there can be multiple traffic for multiple VNets, would they be modeled as separate ENIs? In that case, the number of ENIs should match the number of VNets, right? So just wanted to understand that relationship. Or will all traffic from a given MSE device will always be modeled as a single ENI, and the VNI in the packet will determine the VNet or something like that. So, I mean, I just want to clarify that part, how the VNet and the ENI relationship with the MSE gateway device is determined.
Yeah, so I can definitely help on that. I think we are running out of time. I also need to join another meeting on the 10 o'clock. Yeah. But we can definitely think up on that.
Okay.
Yeah.
So
send me a message offline. I can answer those questions.
Okay. Do you guys need me to start an email thread between the four of us, or let you guys handle it? Riff.
I think we can handle it. Yeah.
Okay.
Yeah.
All right. Well, guys, this has been a big call today. Thank you, Riff, for presenting, and everyone for all the discussion. I did have a couple of things I wanted to follow up on, but I suppose I could carry them over to the next meeting. Please feel free to drop if you need to. I did want to ask Andy how the P4 meeting went last Monday, because my alarm didn't go off. And I also had a question for Susutha, but I can save that until next time. So thanks everyone for coming. I'll turn off the recording. Unless, Andy, did you want to give a quick update?
Thanks, Christina.
Yeah, bye, Michael.
There was the language design work group and the architecture work group meetings. The architecture work group meeting was short, half an hour, mainly a reminder that there is the P4 workshop coming up on October 3rd in Sunnyvale, California.
Oh, yeah, I wanted to do that, yeah.
It's an in-person one, so you need to be physically present in Sunnyvale on October 3rd to be able to attend. But there will be recordings published afterwards if you're not able to attend. But yeah, the architecture work group meeting didn't have a lot of updates, and language design work meeting we're just talking about our usual, adding little new features to language, like for loop.
And I also noticed there's been some updates in the P4, was it the P4 behavioral model work group? But I'll just leave that until next time. That's okay?
Sure.
Yeah. Okay. Thanks, guys, for coming. I hope your 10 o'clocks aren't too angry that we're late. So have a good rest of the day.
Thanks. Bye.
Thank you, everyone. Thank you.